Okay, this is chapter 3, day 8. And this is the last lesson in least squares regression line. And ironically, I started doing this several years ago. I actually explain in detail today what the meaning of the least squares line is. You would think I would do that, a lot earlier in the process, but I found at the very end, if you show the kids, there's kind of an aha moment. Okay. So what I got is some real common sense data. Okay. Weeks you're on a diet and weight loss. So let's say this is one person. So the first week, they've lost 2 pounds. By the end of the second week, they've lost a total of 4. By the third week, they've lost a total of 6. By the fourth week, they've lost a total of 8. And by the fifth week, they've lost a total of 15. Okay. So you can see realistically, it's kind of like they've lost 2 pounds a week for a while. The first 4 weeks, if you look, they've lost 2 pounds a week. And then suddenly they jump. Okay. So a trend line is given to explain to people what would possibly happen. So you may ask somebody may ask you, if you're on this diet, how many pounds will you lose a week? And you might just say about 2 pounds a week. About 2 pounds a week is this equation, y hat, remember, predicted y. You're predicted to lose about 2 pounds a week, x being weeks. Okay, so that is not the least squares line. That is kind of a common sense approach to this. And that line is right here. That's that second red one. Do you see it there? The second red one. I'll put an arrow to it. What's great about that line is it hits 80% of the points exactly. It hits 4 of the 5 points. Okay, so if you remember, the least squares line minimizes the sum of the squared residual. So what I'm going to do is I'm going to get all the residuals for the y equals 2x line. So it's pretty simple to do. And again, let me go ahead and I'm going to highlight this line right there. It's that one, that red one right there. Okay. So if I put 1 in for this equation, I'm going to get a prediction of 2. If I put 2 in, I'll get 4. If I put 3 in, I'll get 6. If I get 4 in, I'll get 8. And if I put 5 in, I'll get 10. The first 4 points hit the points exactly. Okay. So the residual is the actual minus predicted. So 2 minus 2 is 0. 4 minus 4 is 0. 6 minus 6 is 0. 8 minus 8 is 0. And then 15 minus 10 is 5. And if you look at it, you can see that that red line where my cursor is, where this right there, hits those first 4 points perfectly, but misses this one by the vertical gap is 5 units. 1, 2, 3, 4, 5. If I square all of those, I'm going to get 0, 0, 0, 0, and 25. And then if I add all of the residuals up, I get a total of 25. Okay, so remember, the y equals 2x line right here in our example has a squared residual sum of 25. The least squares promises to minimize that. Okay, so I calculated the least squares line and it came out this right here. Okay, it came out this. Y hat equals -2 plus 3x. It's got a slope of 3 instead of 2. It's this line right here where my arrow is. It takes that point, which you could perceive to be an outlier up here, and adjusts toward it. Because if you remember, the least squares line is real sensitive to outlier points. It's non-resistant. It does hit 1 point perfectly. I'll circle it right there, but misses all the other ones. Okay, so let's calculate what this line would predict. So for 1 week, if you put 1 into this equation, it would be, would that be 1 there? It would be 1, okay? If you put 2 into this equation, it would be 4, because the slope is, If you put 3 into this, you'll get 7. If you get 4 in, you'll get 10. And if you put 5 in, you'll get 13. That's the prediction. The residual is y, I'm circling the y's, minus the y hats. Remember that? Y minus y hat is a residual. So I'm going to do that now. 2 minus 1 is 1. 4 minus 4 is 0. That hit it perfectly. 6 minus 7 is -1. 8 minus 10 is -2. And then 15 minus 13 is +2. A reminder, the least squares line zeroes out the residuals. The sum of all of the residuals is 0 because it balances them. You can see how that line, which again, where my arrow is there, it balanced all those points and put a line right in between them. Okay, so if you add them up, you get 0. However, if you square them, I'm going to get 1, 0, 1, 4, and 4. And if I add those up, I get 4, 8, 9, 10. If you remember, the previous sum was 25. So this is much less. That's what that line promises to do. It promises to make the sum of the squared residuals as small as possible. There is no other way to get that sum less than 10. Okay, so that's kind of cool when you see an example of what least squares mean. I really like that prompt. I like doing it last because I think it fills in the gap at the very last second in this kind of mini lesson. Okay, so let's answer some of these questions. Okay, what is the sum of the square residuals for each line? We did that. Okay, one was 25 and one was 10. We did that. Okay, explain the meaning of least squares. No problem. The meaning of least squares is the line that minimizes the sum of the squared residuals or residual squared. Okay. C, what is the y-intercept of each equation? What do they mean? Are they realistic? What is the y-intercept in each equation? What do they mean? Are they realistic? Okay. So the y-intercept in each equation is excuse me, is y hat equals 2x. So the y-intercept is 0. So the predicted amount of weight lost at week 0 is 0. That makes perfect sense. The other one, even though it's the least squares line, it does have an unrealistic y-intercept. Y-intercept is -2, so the predicted amount of weight lost at week 0 is -2 pounds. Not realistic. That is, unless you're, deciding to eat a bunch before you go on a diet or something, but it's not realistic. Okay. And the last thing, is the least squares regression line resistant or non-resistant? Once again, it's not resistant. Okay. The y hat equals 2x line did a great job of capturing 4 of the 5 dots. You remember that. It didn't capture that outlier, if you recall. Okay. Because of that point, this is considered a better fit. Okay. But the least squares line is not resistant. It'll move dramatically for 1 point. And sometimes you don't want that. So sometimes the least squares regression line may not be desirable. It's just the one we study in this particular chapter. All right, that's a little mini lesson. I hope that helps. Thanks a lot.